Okay, let's start off the second video with question number 7 on the June 2017 Regents. This question says the solution to the equation, so solution, that means we're looking for x equals. Solution means x equals. So we want the x equals for this equation. Now it's a quadratic, you can tell because of this little square here, that makes it a quadratic. But it doesn't have an x term. If it had an x term, we would have to factor it or use the quadratic formula. But as is, there's one way to do it a little bit simpler. You can use the quadratic formula, you absolutely could. There's nothing wrong with that. But I'm going to choose to do it a different way. And the way that I'm going to do it is by just trying to get the x squared by itself. So I'm going to start off right here. We have 4x squared plus 98 equals 0. If I want to get the x, I'm going to move away the 98 first by subtracting it. Minus 98 minus 98. I'm going to get 4x squared is equal to negative 98. I've got to divide off the 4 on both sides. That gives me an ugly fraction on the right. I can't simplify the fraction on the right. It doesn't simplify nicely, at least. I can't divide 98 by 4, so I'm going to leave it alone for now. What I'm going to do is I'm going to rewrite it. X squared equals negative 98 over 4. And now I'm going to try to get that x by itself instead of an x squared. To get rid of the square, I'm going to square root, but I have to square root both sides then. Something very interesting that you can do on the right-hand side with this square root, and you may not know this. This is a trick that we don't use that often this year. What I can do is I can split the square root. So instead of having one big square root over the whole thing, right, like we have here, we have one big square root, I can put a square root on the top, square root of negative 98, and on bottom I can put a square root of 2 over the square root of 4. So it's like I split it. I put it on top and bottom, split it in half. Now all I have to do is simplify these two radicals and I'll get my answer. The bottom one is very simple. Square root of 4 is going to be 2. Right? So it's going to be something over 2. But the problem is, what can I do with the square root of negative 98? There's a few things I can do, so I'll take them step at a time. I'll rewrite this. The square root of negative 98 over 2. The square root of a negative, you should know the answer to that. The negative will become an I. Now, we know that 98 can't stay under there because there's no 98s in the answer choices. Look at them. No 98s. So I have to try to simplify that underneath the radical. The way that we simplify anything under a radical is we're looking for a perfect square that divides into it. So we're checking, is it divisible by 4? Is it divisible by 9? Is it divisible by 16? Is it divisible by 25? So what I'm going to do is I'll take my calculator and I'll just check a couple of those. So model this in case you're not really sure what I'm talking about. I should open a regular calculator so you don't have to turn your head. I just realized that turns sideways when I open it. So let me open a regular calculator. I just remembered I can do the on-screen. There we go. Okay. So I want to check to see if 98 is divisible by any squares, perfect squares. So like 2 squared is 4, 4 squared, 3 squared, any of those numbers, any of the nice square numbers. So I'm going to take 98 and I'm going to see if it's divisible by those. So 98 divided by 4. Nope, that didn't work. It has a decimal, didn't divide it perfectly. 98 divided by 9. That didn't work either. 98 divided by 16. That didn't work. 98 divided by 25. Nope. 98 divided by, well, 6 times 6 is 36. Not yet. Next, 7 times 7 is 49. Just 49. Okay, 49. So what we're going to do is, since it's divisible by 49, 49 is a perfect square, I'm going to break it up. So this is equal to I square root of 49 times 2 over 2. The great thing about this is 49 times 2 is equal to 98. So we haven't changed anything, just what it looks like. And the square root of 49 is 7. So I can rewrite this whole thing as 7i radical 2 over 2. If we look at the answer choices, you'll notice that they all are not just 7i rad 2 over 2. And the reason for that is when I introduced this square root, right, I put the square root in here. When I put the square root in there, I was supposed to put a plus minus here. Anytime you put in a square root yourself, you have to add the plus minus on the other side. So plus or minus 7i radical 2 over 2. And our answer is going to be 4. I know that was a super long question. It had a lot to it, so feel free to watch it over again, get all the little nuanced pieces to it. I'm going to start with number 8. Which equation is represented by the graph shown below? There's a couple parts to it. The function starts high. If it starts high, sorry for the messy handwriting on that one. It starts high. That means it's a cosine function. A sine function would start at the midline. That's where it would start if it was a sine. So it doesn't start there. It starts up high. So it's a cosine. All of our answers are cosines, so that doesn't help us yet. But what we need to do is we need to look at the amplitude. This is the amplitude. And this is also the amplitude here, from top to the bottom, from the midline to the top, or the midline to the bottom. This is the amplitude. It goes up and down 1/2. That's this number right here. So it's got to be this or this. It's got to be 1 or 3. Now what we need to know is is the frequency 2 or is the frequency 1? Frequency literally means how frequently, how many full waves does this create between 0 and 2 pi. 0 and 2 pi. How many full waves does it make? So let's think. This is only pi, meaning there's a whole nother one of these this way, meaning there would be a whole nother graph over here before we made it to 2 pi. So it creates one full wave. This is the start, and this is the end of one wave. It starts up high, it ends up high. That's one full wave, completes one full cycle. Starts high, ends high. That's one wave. So it would complete 2 of these by the time it reached 2 pi. So our answer is going to be 1. Frequency is going to be 2. Number 9. A manufacturing company has developed a cost model, big function, c of x, the cost function, is equal to 0.15 x cubed plus 0.01 x squared plus 2x plus 120, where x is the number of items sold in thousands. The sales price can be modeled by S of x, so sales is S, and S of x is equal to 30 minus 0.01x. Therefore, revenue is modeled by R of x is equal to x times SX. R of x is equal to x times SX. So this is a little messy. They want you to find R of x just by multiplying x and S of x, which is the function that we have over there. They want you to just multiply the two. And that's r of x. So what they're telling me, I'm just assuming that I need this. I haven't looked at the question yet, the full question. So I'm just assuming they want me to find r of x. R of x is equal to x distributed into the s of x function, which is 30 minus 0.01x. So when I distribute that x in there, I get that r of x is equal to 30x minus 0.01x squared. That's the r of x function. It's not my final answer, but it's necessary. The company's profit, I'm reading the next line, the company's profit, P of x, that's the profit function, is equal to R of x minus C of x. So in the end, it's just a huge, wordy, complicated looking subtraction of functions with like terms. That's it. That's all it is. So they say P of x is equal to R of x minus C of x. Well, I know R of x, it's right here. And I know C of x, it's right up here. All I have to do is subtract them. 30x minus 0.01x squared minus 0.15x cubed plus 0.01x squared plus 2x plus 120. Now here's the only trick to this. This is where they get you. Where they get you is if you don't realize that the minus needs to be distributed onto all of these terms. That's the trick. That's it. Whenever you're subtracting polynomials, you have to distribute the negative. And then we just combine like terms. That's it. So I'm going to get 30x. There's a lot of writing for such a simple question, but it is what it is. It's a 3-hour test, plenty of time. Minus 0.01x squared minus 0.15x cubed minus 0.01x squared minus 2x minus 120. Now I just combine my like terms. I'll use different colors to underline the different terms that are like. This is a x squared, and this is an x squared. This is an x, and this is an x. And the other two terms are all their own. There's nothing like with them. So what I'm going to do is I'm just going to bring them down. I'll bring them down in size order with the exponents. So x cubed is going to come down first. So minus 0.15 x cubed. Now the x squareds, those are going to combine, minus 0.02 x squared. 30x minus 2x is positive 28x minus 120. All I have to do is match it up with my options, and it looks like it is option number 2. Option number 2. Go back to the full work if you want to take a look at it. Pause on that for a second, see where everything came from. Feel free to rewatch it. I know it's a lot. I'll move on to number 10. A game spinner is divided into 6 equally sized regions as shown in the diagram below. For Miles to win, the spinner must land on the number 6. After spinning the spinner 10 times and losing all 10 times, Miles complained that the spinner is unfair. At home, his dad ran 100 simulations of spinning the spinner 10 times, assuming that the probability of winning each spin is 1/6. By the way, that's a correct assumption. It should be 1/6 chance of landing on each one because there are 6 options and they're all equally sized. So the output of the simulation is shown in the diagram below. These are the proportion of sixes. Proportion of sixes. Now here's the thing. How many sixes did Miles get? He got 0 sixes out of 10 spins. 0 out of 10, or 0 to 10, is equal to 0. Essentially, they're asking, Miles's result, this is Miles' proportion, is 0. The question is that a weird proportion to get? Is that unexpected? Well, let's take a look at our graph here. The mean is 0.157, which is somewhere over here. The mean's about here. And the standard deviation is 0.109. So if I subtract 0.109 twice, I'm going to get somewhere over here and somewhere up here. This in here is a normal range. That's a normal range. There's nothing weird about getting a value in here. And take a look. 0 is in here. 0 is in the normal range. These are expected values. So it shouldn't be surprising at all that Miles got 0. This makes sense. It's not weird. So what explanation is appropriate for Miles and his dad to make? The spinner was likely unfair? No. The spinner's fair? Probably. The spinner was likely unfair? Not a chance. 0 is in the normal range. It's not unfair. The spinner was likely not unfair, since the number 6 failed to occur in about 20% of simulations. This is the 20% they're talking about. This looks pretty good. Let's read the last one. The spinner was likely not unfair, since in the output, the player wins once or twice in the majority of the simulations. That's irrelevant. Has nothing to do with this. 3 is the reason why. 20% of the simulations, 1/5 of the time, there were no 6s. That's not weird. That happens plenty often for Miles to get 0 6s. That's not weird. Question number 11. 2 more questions left, and then we'll stop this video. What binomial is a factor of x to the 4th minus 4x squared minus 4x plus 8? There are different ways to figure this out. You need to remember what a factor is. Remember what a factor is? A factor means it divides in evenly with no remainder. Divides with no remainder. So do you want to do 4 divisions? Probably not. 4 divisions doesn't sound like fun. What we want to do is we want to use the remainder theorem. You might not remember the remainder theorem. I'm not going to write out the full words of it right now, but I'll remind you the name of it, and we'll use it. The remainder theorem says that if you want to know if a binomial, right, like x minus 2, if you want to know if this is a factor, all you got to do is take this and make it positive 2, and then plug it in for all the x's. Oh, there's no x over there. Okay, plug it in for the x's, and then evaluate it. So let me show you what happens. The answer is number 1, but I'm going to show you why. So I want to plug in positive 2, whatever the opposite sign is. So if it was like this one, it'd be negative 2. If it was this one, it'd be positive 4. If it was this one, it would be negative 4. So you just switch the sign. So I'm going to plug in positive 2, because I'm going to check for answer number 1. If I plug in positive 2, x to the 4th becomes 2 to the 4th, minus 4x squared minus 4 times 2 squared, minus 4x becomes 4 times 2 plus 8. 2 to the 4th is 2, 4, 8, 16. This becomes 4 times 4, so this is minus 16. Minus 4 times 2 is minus 8, plus 8. Well, these are going to cancel out, and so will these. We'll be left with 0. And a remainder of 0 means factor. So when I plug in that number, I get a 0. That 0 is the remainder, and that remainder means that our answer is number 1. Last but not least for this video, getting a little lengthy here, some very long questions in that section, so forgive me that the video ran a little longer than I expected. Number 12. Given that sine squared theta plus cosine squared theta equals 1, and sine theta equals negative radical 2 over 5, what is a possible value of cosine theta? So they've given us what sine theta is equal to. Sine theta is equal to this. This right here is just sine theta squared. So we're going to use this equation, we're going to plug into it. And I'll move over to give myself a little bit of workspace, but I'll rewrite the function so that you don't have any issues with that equation. Okay. So the function is sine squared theta, which is the same thing as sine theta squared, plus cosine squared theta, which is the same thing as cosine theta squared, is equal to 1. Now they tell me what sine theta is, so I'm going to plug in negative radical 2 over 5 in for sine theta, plus cosine theta squared is equal to 1. On the left-hand side, you can do this with a calculator, but it's going to give you a decimal. I'm going to do it by hand. When you square something, it means multiply it by itself. So I'm going to go off to the side here, but bottom left, negative radical 2 over 5 times negative radical 2 over 5. This is going to be, so negative times negative is positive. Radical 2 times radical 2 is going to give me radical 2 squared. Those cancel. 5 times 5 is 25. So this is equal to 2 over 25. I'm going to erase this, so just, maybe pause it if you want to use that. So 2 over 25, that's what the left side's going to be. So 2 over 25 plus cosine theta squared is equal to 1. I'm going to subtract the 2 over 25 from both sides. You can do this in your calculator and then just like math, enter, enter it. You can do math, enter, enter, that'll turn it back into a fraction. What I have now is I have cosine theta squared is equal to 23 over 25. Now to get cosine theta, I need to square both sides, or square root rather. My bad, mistake. I misspoke. Square root both sides to cancel this out. I'm going to get cosine theta is equal to positive or negative square root. Now remember that square root trick from before, right? That I could square root 23 and square root 25. Split it like that, so top and bottom. On the bottom, the square root of 25 is just 5, so I can take it out from under the square root. So that's what cosine theta is equal to, and that's what they wanted. They want the value of cosine theta. They don't need theta, just cosine theta. So I don't need to get rid of the cos. So cosine theta is equal to plus or minus square root of 23 over 5. So this right here is plus square root of 23 over 5. That's the answer. Remember that you can always go to JMap, and you could open up this Regents fresh if you want without all of my writing on it, jmap.org. Click on Regents, which is on the left-hand side, and you can click on the PDF document under Algebra 2, June 2017. If you want to do any of these fresh without all my writing all over it, and remind yourself what's up with these questions. Okay, cool. Next video will be up probably tomorrow. So, yeah, good luck.